Welcome. We're going to try something here and just do a quick recording for 10 minutes actually on QuickTime. You'll be seeing that the big thing nowadays is to put your videos out in HD out on YouTube, and that will be one of the conduits we use here. But right now we're just recording on an iMac computer. It's about a year and a half old. It's a 2 gigahertz processor. I am using the iSight camera. I could be using my cell phone. I could be using any number of things. Every now and then you'll see me looking down to look at the feed for the 10 minutes. But I'm going to take a little bit of time here to talk about the general lay of the land with regard to math. And there is mathematics, and then there what I would call math. You see my arms are out of the screen here. It would appear that many people coming through primary and secondary education process aren't or do not necessarily internalize or relate the different areas and different ways in which we naturally do math. With some of the more standard ways being algebra, geometry, computation, just pure arithmetic, or eventually some of the natural things we do on our daily lives being statistics, differential and integral calculus. You may not think that you're doing these things every day because you may not even know what they are, but realistically, anytime you're dealing with things that move or change, you're dealing with calculus. Anytime you are making calculated decisions to cross a street, calculated decisions what program to pursue, calculated decisions to even which girl, boy, or friend you go out with, you're using statistics. So we do want to very early and often, especially when we start looking at computation, step back and think about the larger pieces of the mathematics. So for instance here, I've gone on 2 minutes and 21 seconds. And as I look down here, have I done any math here? Well, let's see. I've limited the movement of my hands, which is going to be one of my tendencies. Perhaps I've limited the movement of my swinging back and forth, and I definitely have limited the movement of the dragon. Right? The dragon has been stationary. Therefore, mathematically, you'll see, we have to give him a name, the position vector of the dragon, which is right over the camera there, that's who I'm speaking to. Position vector hasn't changed. Therefore, his velocity has remained the same and his acceleration has remained 0 with respect to me. There I go again, talking about terms like velocity, acceleration. Those would seem to be physics terms. Physics is the application of math to the physical world. So, that said, let's go through with a few things that I'm going to tend to very quickly use to assess how much students get the math, and not necessarily the math in the formal sense as you might see on an exam. I am not diminishing of that, but you will hear me say over and over again that if the person on the left of me knows that 3 plus 4 is 7, and the person on the right of me knows that 4 plus 3 is 7, and I trust both of them and their ability to kind of think and process and understand, then my knowing that 3 plus 4 is 7 is not always that value added. It may be more important that I know that those two people are trustworthy with their numbers, or maybe just as important, know that they're not trustworthy with their numbers. So, that said, here's some of the things that you should very quickly understand about mathematics, or about pure algebra or computation. Let's start with this. One of the most standard ways to express a line, with the y being the dependent axis and the x being the independent axis, is to write an equation of the form y equals mx plus b. That's called the slope-intercept form of an equation. Once again, one of the most standard ways to write an equation, and we'll see why it's a standard way. Y equals mx plus b, where the b is essentially what the value of the y would be when x is 0, or you'll hear it more aptly said this: it is the y-intercept. It's the point where the line, if we go back to that, y equals mx plus b is the equation of a line, a two-dimensional line. In the form of the equation y equals mx plus b, the m is the slope, the b is the slope-intercept. You will see in much applied mathematics, chemistry, physics, economics, that very often, even though we learn and teach in math that y equals mx plus b is the preferred way for you to kind of get your arm or your head around a line, we write it in some other format. We might write it equals y equals b plus mx. And so it becomes very important for one initially to be able to kind of take out a piece of paper and a pencil and rearrange things so you can then visualize what these things mean. So we know what the b means. The b is where the function or the line crosses the y-axis, where x is equal to 0. What does the slope mean? The best place to start with slope is that the slope of a line that is at 45 degrees, let me get my arms here wrong, the slope of that line is 1. The slope meaning the change going up, or the change in the y, divided by the change in x. And so if you start with the slope being of a line, the equation of that line, just so you know, is y equals x. Is a 45 degree. Wait a second, Mark. You said the form of the equation is y equals mx plus b. Another thing we need to very often realize is if we're going to learn to really process equations and understand what they are shape-wise, is we're going to need to insert fillers where there are zeros or ones. So when I write the equation y equals x, it's the same thing as y equals 1x plus 0. Therefore, b is 0, the slope-intercept is 0, and the slope is 1. For every change in 1x, we have a change of 1y. Starting with that base equation, you will understand start to really grasp and grapple with what the equation, the basic slope-intercept equation of a line is. And I leave you this, you'll hear this so many times that eventually I'll just look to you all and you'll just say, okay, we know, all right? And that is this. We all know that the North Star is north, and pretty much due north. It's off by a little bit. My question to you all is, what is the elevation angle? In other words, from the horizon looking up, what is the elevation angle of the North Star in this area? Or better yet, maybe at the 45th latitude. Latitude being the ladder of the lines going across the globe. So what is the elevation angle of the North Star? What this is going to do, I believe, and it's something that I'll talk about over the semester and over the next 20 years, is it's going to ground us in some basic equation of y equals mx plus b, with m being equal to 1, b being essentially the Earth's elevation or your shoulder, and then we're going to go up from there. So we know eventually that the slope of something that is, going to get this wrong, that is horizontal has a slope of 0. The slope, or m, goes from 0 to 1 between an angle of 0 and 45. And then it goes from 1 eventually to something called infinity, or unknown, as it's straight up. Thanks for listening. We're coming right on 10 minutes. I'm going to stop it right on the dime. See ya.